Hello, welcome to this lesson. In this video, I'm going to learn about cumulative distribution functions. Okay, so a cumulative distribution function, CDF, is a function that describes the probability that a random variable takes on a value less than or equal to a given value. In simpler terms, it gives the probability that a random variable is less than or equal to a specific value. Okay, so that's what the cumulative distribution function does. So I'm going to use an example to explain this to you. So let's say we are performing experiments where we rolled a first six-sided die. Okay, we can get the random variables to be 1. Okay, discrete random variables, okay, to be 1, 2, 3, 4, 5, and 6. Okay, and let's say this is a fair die, so let's consider the probability of getting a 1 to be equal to 1 over 6, and then the probability of getting a 2 also to be equal to 1 over 6, and then the probability of getting a 3 also to be equal to 1 over 6. Then probability of getting a 4 is also equal to 1 over 6. Their probabilities are equal. So probability of getting x equals 5 also is equal to 1 over 6. And then the probability of getting x to be equal to 6 also is equal to 1 over 6. So we have the possible values that the random variable x can take, okay, and then we have what their probabilities also. All right. So the cumulative distribution function says that what it gives the probability that what a random variable is less than or equal to what a specific what value. Okay. So let's say these are our random variables. Okay. So let's say that you want to find the probability that the random variable, okay, is less than or equal to what? Less than or equal to what? 3. Okay. Let's say I ask you to find the probability that what the random variable what is less than what or equal to what? 3. This is what the cumulative distribution function says we should do. So it gives us the probability that what a random variable what is less than or equal to what a specific value. So we are finding the probability that what the random variable x is less than what or equal to what 3. So in this case, if you're asked to do this, you just have to what add the probabilities of all the random variables that are what less than or equal to what 3. So if you're looking at x values that are less than or equal to 3, then you are going to have 1, 2, and then the 3 itself, right? So what you're going to do is that you're going to add the probabilities of what all these 3 values. Okay, so you're going to have the probability of getting x equals 1 will be 1 over 6, plus the probability of getting x to be equal to 2 will be what 1 over 6, and then the probability of getting x to be equal to 3 will also be what 1 over 6. So then you're going to get what 3 over 6, which will be the same as what 1 over 2. So that will be the cumulative distribution, okay, for the values of x less than or less than or equal to 3. Okay, so this is what the cumulative distribution function is about. Okay, so you may be asked to find the probability that x is less than or equal to 4. Okay, so in this case, you are going to have 1 over 6, right, plus 1 over 6 plus 1 over 6 plus what 1 over 6, because you are going to consider x values in this range, which will be 1, 2, 3, and then 4, right? So in this case, you are going to get what 4 over what 6, right, which will give us what 2 over what 3. So this is what the cumulative distribution function is about. It gives the probability that a random variable is less than or equal to a specific value. Okay, that's what it means. Okay, so now let's look at these definitions and then properties that I have here. Okay, so let's look at the definition first. It says that the cumulative distribution function of a discrete random variable x is denoted as what capital F of x. Okay, it is denoted as what capital F of what x, and then this can be denoted as the probability of what the x values less than or equal to what x, right? And then this is the same as the sum of the probabilities of what f of what xi for xi values less than or equal to what x. Okay, this is how to express the cumulative distribution. So let's look at the properties. Okay, the first property says that the cumulative distribution function, okay, which is capital F of x, is the same as the probability of capital X less than or equal to small x. Okay, and that should be equal to the sum of f of what xi for xi values less than or equal to what x, okay, which is just like the definition. And then the second property says that the cumulative distribution function should be between what 0 and then 1, okay. So capital F of x, okay, should be greater than or equal to 0, or should be what less than or equal to what 1, okay. That's the second property, okay. And then the third property is that if x is less than or equal to y, okay, then the cumulative distribution function for x should be less than that of what y, okay. That's another property, so let's take note of this. So this is what the CDF is, which is the cumulative distribution function is, okay. So it gives the probability that what a random variable is less than or equal to what a specific value, okay. Let's take note of this.